We have talked a lot about types, about primitive types, and we have said that a type is a set of values and the set of operations that we can perform on those values. So for almost every primitive type, we saw what are those values and what are the operations that we can perform. Now we can combine variables and literals all together. They may be of the same type, but they may be of different types, and have operations among them. And this is how we form expressions. For example, we may have x being added to the literal 5, and then the result being divided by 2.3, and all that expression being assigned to a different variable, say y. In order for us to be able to evaluate that expression, in order to know how to perform the operations and how to find the final result, we need to know what is the order in which we should apply the operations. In other words, we need to know the rules of precedence. And like algebra, we follow the same rules for the mathematical operators, so division and multiplication have higher precedence over subtraction and addition. Just to remind ourselves, let's take a look at an example. We have an expression being assigned to a variable. Now, how are we going to evaluate the expression? We're going to first perform the operations that are grouped as you see in the parentheses. So, after we have performed the multiplication c times d, the result will be added to variable b. After the division a by b is performed, and after the division of that result by d is performed, then we're going to perform the subtraction of the two sub-expressions. And the final result will be assigned to variable x. Here is a table that shows the precedence of the operators from highest to lowest, and I invite you to actually visit with me the very last line of the table and see that at the very bottom of the precedence is the assignment operator. What does that mean? It pretty much means that before you assign a value to a variable, you need first to evaluate all of the expression. You shouldn't take a sub-expression, assign that to the variable, and then continue evaluating the rest of the expression. This is why the assignment operator has the lowest precedence. Everything else needs to happen first, and the final step will be assigning the final result to that variable. Now, on the top of the precedence table, we also see, as we would expect, the unary operators, which is pretty much the sign. Positive numbers don't have to have the plus sign, but they could. And then after that, multiplicative operators, including the modulo operator, and then subtraction and addition, as we would expect. In the table you also see operators that we have not talked about yet, like the shift or the bitwise operators. These are operators that are very useful when we're actually doing operations at the binary level. For example, we can be adding 2 bits or multiplying 2 bits, or we may be shifting a number, shifting the bits of a number left or right. These are operators that some of them we will see later on. We have talked, however, about the logical operators when we talked about the Boolean type. At the link at the bottom of the slide, you can visit that link and find out more about the operators that you see, and also find out the longest list, a longer table, I would say, with operators and the precedence of those. And again, several of the operators that you will see at the link, but they are not on the table, we have not talked about yet, and that's why we have not included them yet. We will see them later on. Now, there are 3 questions here that we should be puzzled about, that should be making us a little bit uncomfortable. What happens when inside an expression we have values of different types? We already said that this is possible. However, what does it mean to actually add a short and a long? What will the result be? Will it be kind of a compromise? Will it be an average, for example? What does it mean to add a double to an int? These are the questions that we will try to answer in the following slides at the rest of the video. And the answer comes through casting. To cast, it means to convert from one type to another, convert from a value of one type to the value of a different type. And we have two types of casting. One is the upcast, where we are going from a narrower type to a wider type. And here what we mean, what we are counting is the size of the representation. How many bits are we using in order to represent a particular value? For example, if we are going from a short that is represented with 2 bytes to an int that is represented with 4 bytes, or if we are going from a float to a double. These are examples of upcasting. A little bit more troubling is the other way around, is the downcast. We are going from a representation that has more bits to a representation with fewer bits. For example, we're going from a double to an int, or from an int to a byte. What happens when we try to do something like that? In this diagram, you see what we call the type promotions. In other words, what is safe and pretty straightforward to do when we are upcasting. Upcasts or type promotions happen silently. We as programmers don't have to do anything explicitly. Java will take care of that because there is no problem. There is no possibility of having a mistake happen. For example, if we go from an int variable to a long variable. Suppose that we are defining variable L. Long L becomes equal to 42. There is no trouble there. 42 is a literal that is of int type, and it is being assigned to a long variable. It is perfectly fine. 42 goes from 4 bytes to a larger representation, to 8 bytes. There is no problem on losing precision or losing any data, and Java will silently do such a promotion for us. So all the conversions on the way that the arrows show are fine. Or conversions on a different direction might create problems and are actually not done automatically.